Hundreds of amps through your frozen pipe, more current than a welder. Sounds like a recipe for disaster. But that's exactly how electrical pipe thawing machines work, and why nothing gets destroyed comes down to one surprisingly simple principle. Instead of baking the pipe from the outside with a dangerous flame, this machine turns the frozen pipe itself into an active power line. Before we see how, remember this explanation is for informational purposes only and is not professional plumbing advice. To start, two conductive metal clamps are attached to the pipe, flanking both sides of the frozen blockage. These clamps do not produce heat on their own. Instead, they serve as the doorway for electricity. The current travels from the machine into the metal pipe wall, past the internal ice, and back out. This complete, unbroken loop of metal is the absolute baseline requirement. Without a closed circuit, nothing happens. But when that loop closes, the magic begins. How does sending electricity through cold metal generate heat on the inside? The machine does this with a simple electrical trick, swapping high voltage for massive current. It plugs into a standard 115-volt household wall outlet, drawing about 15 amps. Inside the cabinet, a transformer steps that voltage down to a completely safe 6 volts. Because the voltage is so low, similar to a toy battery, there is no risk of a nasty electric shock, even in damp basement conditions. But as the voltage drops, the current, the actual volume of electricity, skyrockets into the hundreds of amps. This massive flow triggers a physics principle called Joule heating. When those hundreds of amps squeeze through the pipe, they collide with the natural electrical resistance of the copper or steel. This resistance acts like physical friction on a microscopic scale. Just like rubbing your hands together on a freezing day, this electrical friction generates rapid, intense warmth directly inside the metal walls. Because the pipe itself acts as the actual heating element, the heat blooms from within, melting the ice from the inside out without ever needing a dangerous open flame. As the metal pipe warms up, the ice inside doesn't just instantly vanish. Instead, the melting begins right at the boundary where the cold ice grips the hot metal wall. This creates a thin, slippery jacket of liquid water around the solid plug. Even before the entire ice block is gone, this lubricating layer loosens the clog's grip. Now, the plumbing system's natural water pressure goes to work, pushing against the loosened plug. The moment a tiny pathway opens, pressurized water forces its way through, carrying a slushy mix of ice chunks and meltwater downstream. This rushing water actually helps finish the job by dragging the remaining ice away. Once the tap starts flowing, the continuous run of water prevents refreezing, proving the circuit did its job. Putting this technology to work follows a straightforward, step-by-step checklist. It starts with a quick inspection of the pipe run to locate the frozen section. Next, the heavy-duty clamps are attached on either side of the icy blockage, and the machine is briefly energized. The operator closely monitors the setup, and the second that water starts flowing, the power is switched off. However, this clever shortcut only works under very specific conditions. The process is built strictly for conductive metal water lines, such as copper, steel, and galvanized iron. Applying hundreds of amps to non-conductive, heat-sensitive plastics like PEX, PVC, or CPVC is a major hazard, as these materials can easily melt, burst, or even ignite. Even with a perfectly compatible metal pipe, success hinges entirely on the quality of the connection. For electricity to flow, there must be clean, direct, metal-to-metal contact. Any barrier, whether it is a layer of paint, rust, corrosion, or leftover insulation, can completely block the current or cause dangerous electrical sparking. While this overview shows how the machine is used, remember that this video is for informational purposes only and is not professional plumbing advice. Always call a licensed pro to handle frozen lines safely. Every freeze is different, meaning there is no single countdown timer. A tiny ice plug in a half-inch pipe might melt in just a few minutes, but a long, severely frozen run under cold exposure can take much longer. The machine's success depends entirely on the situation, like pipe diameter, wall thickness, and real-world temperature, rather than a single preset setting. Because managing these electrical forces can get unpredictable, remember this video is for informational purposes only and is not professional advice. When a freeze is stubborn or uncertain, Always call a licensed plumber or electrician. When winter freezes your pipes, simple physics saves the day. Just remember, this video is strictly informational, not professional advice. Subscribe for more everyday science.